All right, let's go ahead and talk about casting, incrementing, and decrementing. So we'll create another one. So public class, I'll call it increment, decrement, and casting. Create our own public static void main string args. And what exactly we want to do. So what does it mean to increment? Increment means to increase the value by 1. So for example, I have an int, I'll call it index equals 0. Well, how do I get index to be equal to 1? Well, I could say index equals index plus 1. And let's do a system out print line index and see how that works. I have to save this, of course, and save. Okay. So now it's equal to 1. That's great. Okay. I can even write a little note. Index. And index equals, and have that nice little line there. And it'll say index equals 1. Okay, so far so good. Well, isn't there an easier way to do this? Index equals index plus 1. You see, one of the things that makes programmers special is we're very lazy. Oh, I mean, efficient. Yeah, it's the same thing. Lazy and efficient. That's a lot of typing here when all I have to do is do plus plus. So, what happens when I do a plus plus here? Compile that. Hey, look at that. Index equals 2. What I'm doing is I'm incrementing it. Index plus plus is exactly the same as index equals index plus 1. That's pretty cool. So I can also, if I wanted to, do a plus plus here. Now that can be kind of confusing because there are two types of increments. Post and pre-increment. This one is a post increment. What happens when I run this? Okay, index equals 1 and index equals 2. Let's figure this out. We create a variable of type int equals 0, then we increment it by 1, and we print it out. So 0 plus 1 equals 1. That makes sense. Then I do index plus plus. All right, that makes it 2. And then I say index equals index plus plus. Well, what this does specifically is it's going to be have an expression that does two things. This first part of the expression will say index equals, that's a string, concatenated with what's the value of index? Well, the value currently is, after that line, 2. And then what this plus plus does at the very end is it changes it and increments it after everything else has been done. So this would be the same if I took this out and put the line right there like that. But we're lazy. Programmers don't like typing a whole bunch of extra times. So I can just do plus plus. Let's go ahead and see what happens when we, oh, that's the wrong thing. Let's see what happens when we print out this again. All right, 1, 2, 3. I can print it out again, and it should still be 3. All right, this is kind of confusing, so let's go through this again. Right here, we have index equals 0, so value equals 0. And then value equals, well, what's 0 plus 1? 1. And here, value equals 1. Okay. And then what's the value at this point? Value equals, well, 1 plus 1 is 2. And then here's the tricky part. Value before the plus plus equals, before the plus plus it equals 2, after the plus plus it equals 3. So what does this line do? It says index equals, and what is the current value? 2. And so it prints it out, and then after the fact, it increments it. So with here, I just go ahead and I'm just printing it out, and I'm not incrementing it. Now here's an interesting thing. There's a post and pre-increment. Well, this one says index equals 2, and then after you print it out, assign it to be 3. I print it out, and it is 3 right here. Let's run that again. It all makes sense, hopefully. If not, go through this several times until it does make sense. And then here, index equals, what happens when I put a plus plus beforehand? What this is doing is it's saying index equals, oh, by the way, before we print out index, increment it. So this will increment it before it prints it out. So now it makes it a 4. And there are two different things. So for example, you could do index plus plus, which is the addition, the increment adds. But there's also index minus minus, and this decrements or subtracts. Let's go ahead and look at an example. So we'll say int num equals 5, and then we'll say num minus minus. So system out println num equals num. So what value will that be? Will be 4. So num equals 4. Now let's see what we have here. Let's see what happens when we do a num minus minus. What do you think will be the value when it prints out? It'll say index equals 1, 2, 3, 4, then it'll say num equals 4, and then what will be the result of this line? Let's see. Equals 4. Well, why is that? Because it's a post decrement. If we print it out now, then this just prints out the result of that, which was 4. And this prints out this part, which is the same number. And then after the fact, decrements it, and this just prints it out. So let's go ahead, and this should be a 3. There you go. 4, 4, 3. Now, what happens when I do a pre-increment? We know it's going to be a 4, it's going to be a 4, it's going to be a 3. But what happens when I do a pre-increment? When I do a pre-increment, it should be a 2, because it changes it before the fact. All right. Well, that takes care of post and pre-increments. Let's see here. There's some other interesting things you can do. Like, for example, you can say num plus equals 5. And this is a compound assignment, which is the same as num equals num plus 5. And there's a whole bunch of them. You can say num minus equals 5. You can say num divide equal 5. You can say num times equal 5. You could even say num modular division equals 5. And of course the number doesn't matter. These are just all compound assignments. Well, that should compile fine. Good. The last thing we need to talk about in this video is casting. So suppose I have a double. I call it pi, and that equals 3.14. And I have an int, and I'm just going to call this num6, and that equals pi. Well, that's not going to work. It specifically says right here, incompatible types, possible lossy conversion from double to int. Ugh. But what if I really just want the 3? I know that when I convert a double, this pi, to an integer, I will lose the 0.14. I know that. And Java won't let me do it. It says, you know, you just cannot lose that. Well, I can force it. I can say, hey, I really want to cast or convert. So cast, which means to convert from double to int. And if I do it this way, it works out all right. I actually succeeded. I can even print out num 6. So num 6 there. And what are we going to get? We should get the number 3. And lo and behold, we got 3. What about casting? Now this is explicit casting. When you put this parentheses and say, in my assignment statement, I want to convert from this data type, which in this case is a double, to this data type, which is an int. I'm casting as an int. I'm doing explicit casting. Well, what if I have a situation where I have int num7 equal 8, and then I want to do double num8 equals num7. Well, let me do that. Yes, it has no problem. The reason is, and this is called implicit casting, is we aren't losing any information. This is an 8, and I'm going to put it into a double, and so it's actually going to become 8.0. So all you would show that, system out print line, and then num8. There we go. There's our 8.0, which is a double. You can do any casting you want from any of the numbers to any of the other numbers. And we'll talk a little bit about the char primitive in the next video.